One of the really interesting things about working with ecosystems is that there's sometimes really subtle background processes, things that you can't see happening, but can actually have a really big impact on how the ecosystem functions, on the productivity of that particular ecosystem. Hi, welcome to the Lear Innovations channel. My name is Edmund Williams, and today we're going to be talking about one of those, which is the fungal to bacteria ratio. So the easiest way to describe what the fungal to bacteria ratio is if you look back to your high school biology. There's a graph, a chart that they like to show pretty frequently in that, and that chart it shows, we start with disturbed soil. So the soil has been disturbed, whether it's a natural disaster, plowing, something that has disturbed the functionality of the soil. And then as that soil starts to heal, you get a progression of ecosystem types. So what happens is at the very beginning, once it's fully disturbed, you'll get annuals that grow in that. And then eventually, as that begins to heal, you'll move to a grassland and then on to a shrubland, eventually to a deciduous forest, and then the final is a coniferous forest. Now, it turns out that that graph is exactly the fungal to bacterial ratio progression. So, if you look at the fungal to bacterial ratio down here, the annuals are going to see 0.1, 0.2, something like that. As you move up a little bit higher to a grassland, you're going to have, let's say, a 0.8. Somewhere between the grassland and the shrubland, that's where it switches over. It crosses that threshold of a fungal to bacterial ratio of 1. And again, remember, it's a fungal to bacterial ratio, so it's amount of fungus divided by the number of bacteria. And then, of course, by the time you get to the coniferous forest, you're looking at a fungal to bacterial ratio of, say, 200. So, what are the biological processes that are causing this? So the fungus exists as a series of cottony threads, and when that disturbance happens, when the soil is churned up, it breaks those threads. Sometimes it just disturbs the fungus and they return, but actually in a lot of cases it'll actually kill that fungus element. And then the fungus is going to take some amount of time to recover. So in terms of the biological processes, in a bacterially dominated soil, you get these biofilms are created by nitrogen consuming bacteria. They consume the ammonia and convert it into nitrate. They also raise the pH. So you're going to have slightly alkaline soil, say 7.5 to 8.0 typically. And so those are the conditions that are going to predominate. But then what happens is as the fungus begins to recover and it comes back in, the fungus actually uses acid to digest a lot of its food. It uses very, very small amounts of very concentrated acid. And what will happen is those bacterial films that are supporting the nitrogen consuming bacteria are an alkaline film, and that acids that the fungus is producing start to dissolve and neutralize that film to the point where eventually you get to a point where those bacterial colonies kind of collapse, and then the fungus will begin to predominate in that situation. So that's the basic biology of what's going on. So why is it important? There is a form of composting called a Johnson-Su bioreactor. And a Johnson-Su was originally created to sort of make composting easier, as I understand it. But basically what it is, it's a large structure, typically built out of a combination of screen and a fabric like landscape fabric. And it's got these internal channels, and the whole thing is designed so that no part of the interior compost is more than a foot from an air source. Which makes it sort of passively aerating. So it's a compost bin that you don't turn. And typically what they do is they load it up with their recommended mix of what you put in there, and then you let that decompose for up to a year. Well, actually, in some cases I've seen more, but typically it's about a year. And the compost that you get out of there, because you're not turning it, because you're not continually breaking those fungal strands, you can actually run into a fungal to bacterial ratio that puts you into the fungally dominated side of things. And I've heard that the goal is typically a fungal to bacterial ratio of 1. So you're not necessarily looking for something that's like a 200. I have seen tests up to about a 20. And so there's a little bit of variability in there, but you're definitely looking for something that's around 1, give or take. So the results that they're getting from the Johnson Sioux compost are pretty amazing, actually. The typical application rate. So what happens then is it's not just the fungus, but there's also a whole lot of organisms that prefer that sort of those sort of conditions to grow, and those organisms end up being very, very powerful when it comes to restoring degraded soils. And so what they found is that with an application rate of about 2 pounds per acre, 2 pounds of soil is about this much. It's a little bit bigger than a softball size worth of soil. So it isn't. It really isn't very much. And they spread that out on an entire acre. And the people who've done this typically describe the results as somewhere in the neighborhood of miraculous. What those organisms are doing is they're restoring a lot of those biological processes as a biostimulant, and they're causing that growth to increase. I saw one test, and I don't remember what the application rate was on this test. It might have been a little higher than the 2 pounds per acre, but it was an alfalfa field that was degraded. They applied the Johnson Sioux compost, and they saw a 5-fold increase in the output of that alfalfa. So these things are like really important. So again, why is this important? Why am I talking about the results from a Johnson Sioux compost? Because Lear Soil Amplifier is also fungally dominated. I've tested it. Typically comes out around 1.0, give or take a little bit. I'm still trying to understand because of the processes involved. I feel like that number should be higher, and I'm trying to understand that. But the point is that so a Lear garden is, in terms of how it aerates the soil. Instead of a vertical tube, we have a horizontal plane, which isn't practical if you're going to be putting it in your barn or whatever. But if you're actually growing vegetables, that's the preferred format. In our case, the soil depth is only about a foot. And so we get that same 1 foot, and the aeration happens with the flood and drain of soil. So what I'm doing is I'm pushing water in very high amounts, which is going to push the water level up, which is going to off gas the bad air that's inside of the soil, and then when it drains down, it's going to suck fresh air in. So it's basically causing the aeration of the soil. And so that achieves that oxygenation to a pretty high level without actually having to turn it. So again, like the Johnson Sioux, a Lear garden is set up and it is not turned for typically 9 months to a year. And so I think that we can expect similar results. We're still working on finding ways to do those field tests. Those are exceptionally expensive, and we haven't gotten there yet. But if you know somebody who wants to partner with us on that, I'm definitely interested in partnering because I think we're going to have some really interesting results. But stay tuned.